Welcome to the third review, part 3. This is for Earth Science 2, Learning Set 1, What Makes the Weather Change. This is for a review for lessons 1 through 4. And if you look at your success criteria sheet, this is the review sheet that we hand out at the beginning of the unit, or towards the beginning of the unit. And this is for numbers 7 through 9. Again, these videos weren't meant to give you the actual answers and the actual questions that some of the earlier videos did, but they emphasize the key points, the key concepts that you need to know for the test. Now, then it's up to you if you're going to know those key concepts. And one of the things you're going to have to know for the test is a lot of vocabulary. So words like absorption, barometer, equilibrium, humidity, meteorologist, reflection, temperature, thermal energy, weather, wind. Make sure you know what all these mean. Make sure you understand what they are. For example, earlier on some of the quizzes we had, what is a meteorologist or someone who studies the weather? I had a fake word on there called, and it was weatherologist. And probably about a quarter of the students actually clicked weatherologist as a person who studies weather, but weatherologist is just a word I made up. Where if you would have done the readings and if you would be paying attention in class, you would know that weatherologist doesn't exist. It's actually a meteorologist. It's someone who understands and talks about the weather. And meteorology is the study of weather, not weatherology. It's meteorology. So make sure you understand all these words, and if you don't understand them, ask your teachers before you start the test. Don't wait till afterwards and say, well, I never knew what humidity meant. Well, you should have asked. So we do go over all these in class. Make sure you listen, make sure you check them off as you know what they are and as you're studying. Be able to compare and contrast precipitation, condensation, and evaporation. So know how they're all related. They're all part of the water cycle. They're all involved with weather and how they work together. We got evaporation. This is when the sun's energy causes water that's on our planet to change into a gas, and they call that evaporation. That water is in the atmosphere, and when it cools off and when that water vapor changes back to a liquid, it's called condensation. And so a lot of these water droplets together will form clouds. And if those clouds, the rain droplets get heavy enough, they will actually fall as precipitation. So be able to explain how they're all related. And it's got to be a little bit more than a generic, well, they're all part of the water cycle. And then that's it. You'd have to go beyond that. And you'd have to be able to explain how they're related, how they're interrelated, how they're connected to each other, other than simply they're all part of the water cycle. And so, for example, evaporation, condensation, precipitation, they all show how water is moved in and around the atmosphere. Evaporation takes place in the atmosphere to can be condensed and then fall again as precipitation. So if you want the full value, you have to explain each one of them and how they're connected, other than they're all part of the water cycle. And then finally, be able to compare and contrast conduction and convection. Now, in every video we've talked about, or at least in the 3 for this review, we talked about the importance of knowing how conduction and how convection work, how it moves air in the atmosphere, and how it's connected to the weather. So how are they similar and how are they different? So make sure you're able to explain those, make sure you understand the differences between them. For example, conduction, you have to have things in contact with each other. This is you cooking breakfast in the morning and having a frying pan on the stove. The flame is touching the pan, that's conduction. The egg inside the pan is the egg is touching the pan, that's conduction. Where convection is more or less where you have less dense air rising up. You don't have to have things touching each other. So how are they similar? How are they different? How are they similar? They both transfer energy. They both move energy around. How are they different? We just went through those differences. So again, make sure you can explain all these things before the test. Again, as always, if you have questions, ask prior to the test, not after the test. So this is the third and final review. Hopefully these videos help prepare you and let you know exactly what you need to know. Now, these videos don't tell you everything like some of the prior videos have, where they basically were the answer keys to the test. Here you're going to have to put some time and effort into studying. So again, as always, ask questions if you got them.